This is example 3.3, chapter 3, part 3. Determination of beam, shear and bending moment. A series of 250 and 550 mm reinforced concrete beams spaced at 3 meter centers and spanning 7.5 meter support with 175 mm thick reinforced concrete slab are shown in this figure. If the variable floor QK is 3 kN per meter square and the load induced by the weight of concrete is 25 kN per meter cube, calculate the maximum shear force and bending moment of beam B12. So this is beam B12. The span of this beam is 7.5 meter and the space between this beam with the other beam is 3 meter each, and the thickness for this slab is 175. Given the QK is 3 kN per meter square and unit weight of concrete is 25 kN per meter cube, and this is the cross section of the beam. Precast concrete slab. So if the slab is precast, meaning the distribution of the load is in one way. The thickness of this precast concrete is 175 mm slab thickness. The depth of the beam is 400 and the width of the beam is 250. Precast. So for precast, the load distribution is in one-way direction. The output of this example is maximum shear and maximum load. Maximum bending moment for this beam. Okay, let's redo the solution. First, we need to calculate slab load. So the permanent action for the slab is the thickness of the slab 175 millimeter multiplied with unit weight of concrete. So the answer is 4.38 kilonewton per meter square. Then the variable action for slab is 3.0 kilonewton per area as given in questions. Thus, the total ultimate load for slab is 1.35 GK plus 1.5 QK. 1.35 multiplied with 4.38 plus 1.5 multiplied with 3.0. Thus the answer is 10.141 kilonewton per meter square. So this is for slab. Next, beam load. We know that beam load for GK is the combination of self-weight of the beam and slab GK here 4.38. Thus GK for beam self-weight is the width 0.2 multiply with the depth of the beam multiply with the unit weight of concrete, and the answer is 2.5 kilonewton per meter. So this is the unit weight, the self weight of the beam. The self weight of the beam is 2.5. Sorry, the width is 0.25 multiplied with 0.5 for 0.4 multiplied with the unit weight of the concrete, because our material is concrete. Thus the answer is 2.5. So we know that ultimate load from slab. So ultimate load for slab here. So this is our beam in one-way direction. So half go to this beam. So another load distributed to this beam. Same goes to this part, this area. (0.5) and LX. So ultimate load from slab. Ultimate load from slab. Okay, ultimate load from slab here is 0.5 multiply with 10.41, and our LX here is 3. This is for slab number 1. From slab number 2 plus 0.5 multiply with 10.41 multiply with LX, the same LX, because both slab having LX 3 meter. So ultimate load from slab is 31.23 kilonewton per meter. And for this beam, self weight of the beam, we need to multiply with the coefficient. So the ultimate load for beam is 1.35 for GK equal to 1.35 multiply with 2.5, 3.38 kilonewton per meter. So total, thus, respect the pink color, total ultimate load on beam is 1.23 plus 3.38. (34.61 kilonewton per meter). And finally, for the maximum shear force for simply supported beam is WL over 2. Our W is here is 34.61. The length, the span of the beam is 7.5 meter. Thus, our unit for maximum shear force, unit in kilonewton, the answer is 129.79 kilonewton. Meanwhile, for the maximum bending moment is WL power of 2 divided by 8, 34.61 multiply with the length of the span of the beam, power of 2 divided by 8. So maximum bending moment is 243.35 kilonewton meter. Unit is very important. For maximum shear force, for shear force unit is in kilonewton. Meanwhile, for bending moment, unit in kilonewton meter. Then, when we draw this, so this is our beam. This is the column support. And this is distribution. Okay, so our total ultimate load is 34.61. W is 34.61 kilonewton per meter. Positive, negative here. So here is WL over 2, WL over 2, 129.79, 129.79 unit. This is shear force diagram in kilonewton. For the bending moment, so this is the maximum value for moment, positive. Bending moment diagram, unit in kilonewton meter. So here is 0 at support for simply supported beam. And our value here is WL power of 2 divided by 8. And the value is 243.35 unit in kilonewton meter. We have solved this problem. Thank you.